Hi, everybody. This is Mark Graven from KaiNexus. I want to welcome you to our webinar today. It's titled A Structured Approach to Problem Solving. And very happy to have as our presenter today, Chad Westbrook from AGCO. So with that, let me introduce briefly, just give a quick introduction to today's presenter. It's been really nice working with Chad in preparation for the webinar. Chad and AGCO, they are customers of KaiNexus, and we're really happy that Chad is willing to share with everybody here today. Chad is manufacturing engineering manager and AGCO production system manager at AGCO Corporation, and Chad is going to tell us a little bit more about the company and their products. Chad has a bachelor's degree in mechanical engineering related technologies from Kansas State University. I see the purple in the shirt and tie. Those are see Kansas State colors there, Chad. And with that, I want to give a warm welcome and turn things over to you.
All right. Well, thanks, Mark, and thanks for everybody for joining us today and talking about a structured approach to problem solving. Before we get into that, AGCO isn't a name brand that's used around the house today. So I wanted to give just a little information about what AGCO is. And AGCO is a full-line manufacturer of agricultural products. So we make anything from tractors, sprayers, hay equipment, harvesting equipment, tillage and planters as well. Here at Heston, we build combines as one of our products. We have 3 brands. You'll see us under Gleaner, Challenger, and Massey Ferguson. And with that, we have 5 models as well. We also build round balers. We have 2 brands, both Massey Ferguson and Challenger, and we make 5 different sizes of the round balers. Small square balers, here at Heston, we make 2 brands, both Challenger and Massey Ferguson, and 6 different sizes of the small square baler as well. I'd say our staple product here at Heston is large square balers. We introduced the Fent brand to our large square baler models. We make both Massey and Challenger as well, and we have 7 different models or sizes of these. We also make the hay equipment, the swathers, or the windrowers as we call them, both Massey and Challenger, and 4 different sizes. And then the pull type mowers that you would see typically on a windrower that will also fit behind your tractor for cutting hay. With that, the combine headers and hay equipment headers, we make 3 different brands and models. With that, the corn row, Dynaflex, Draper headers, and then the rotary headers as well. So a little bit of background about the Heston, where we have a very diversified portfolio, I would say. Some seasonal product and some product that will go throughout the year. With those products and that portfolio that we have found many opportunities or problems that we face in our day-to-day building activities. And so we structured the way that we solve problems as before we were really just focused on the containment piece and how quickly we could resolve the issue. What we found with that approach was that we weren't really resolving the problem. We were just, I would say, covering up the issues that we had. Although we would get good product out the door, sometimes we would revert back to issues that we had in the past and then have to go through activities that would create a lot of struggles for us when we were trying to correct the problem. So what we did is develop this structured problem-solving process for our Heston facility. And the tools that we use that we'll cover today will be the 5G process, the 5W1H or phenomena description, our 4M1D and confirmation, 5 Ys, and then the level of countermeasures that are enacted when we define the root cause. Once we get through that piece, we'll go through an AGCO example on how we use the tools. So in the structured problems process, we really look at the initial phenomena, and that's defined by anybody from operator, design, anybody that is at the Heston site. What is it that is creating an issue for them today? The purpose of the structured problem-solving process is to start with the initial phenomena and then identify the root cause and corrective action. When we start with the initial phenomena, this establishes the finish line for us. We can go back after we look at the root cause and our countermeasures, and sorry about that, root cause and countermeasures, and then once we implement the countermeasures, we can look at the initial phenomena and make sure that we've corrected that. So as you see our process, we walk through the 5 Gs. This goes hand in hand with the 5W1H. And as we're filling out the 5W1H, we then will get into the 4M1D and confirmation, followed by the 5 Ys. And from the 5 Ys, we develop the root cause, or we identify the root cause that caused the initial phenomena. So let's walk through the 5G process. Our 5G process, by definition, is a tool used to describe the loss phenomena. This can be for safety, a quality defect, a minor stoppage on the line, or a major breakdown. It can be attributed to a long setup or a part shortage, or etc. The purpose of the 5G is to describe a situation in a complete and detailed way, to keep a proper relationship between theory and practice, and to follow a logical flow during the process. This helps when we're walking through the 5W1H form to identify what the revised phenomena is. We use this when we're the 5G during the first phase of the problem investigation. And we typically walk this through with the 5W1H form so we can fill that out appropriate as we're walking the problem. You'll see some of the terms in 5G process. Many companies or industries use the term Gemba, and that's actually going to the problem. The 5G process includes Gemba, Genbutsu, Genbutsu, Genri, and Gensuko, and we focus really on the first 3. When we look at Gemba, or going to the actual place, we go to the spot of the initial phenomena, and then we start walking that problem back through our processes, whether it be something that some components that we made in-house, or even a supplier that might have had an issue with one of their parts. We'll get them involved through this process. So when we look at the Gemba going to the actual place, that's going to the spot, the workplace, the place where the event actually happens. And don't be tempted to assume you know the problem. There may be things that you'll miss. And that's often what we found when we looked at our problem-solving activities before we instituted this structured problem solving. We would assume that we understood where the problem was happening and then make our countermeasures based on those assumptions. The second, Genbutsu, or the actual things, is to examine the objects. The actual materials, processes, machinery, people, objectives that are actually involved in the event. And when you talk about vertical integration, like we are here in Heston, where we do fab, weld, machine, and laser activities where we make our own parts, this can lead us into walking to many different departments or value streams that we have here on site to fully understand the evolution of that part through assembly. The third one is the actual facts. Check the facts, get the real facts, and analyze the actual data. What actually happened, what you can actually observe with your own eyes, and separate the facts from assumptions. This is where we'll take into account by design, how the part was designed, the tools that were used to make the part, and then the assembly processes that we use when assembling. These first three are really where we focus on. Results in the short office meeting. This gets us to the shop floor instead of behind the desk trying to solve the issue. The last two, Jinri and Gensuku, they can be studied if the experience does not reveal the causes of the problem. So when we look at the principles or theory of parts, when we don't have standard work for certain operations, we can look either towards our planning or to the operator and get a clear understanding of what they believe the theory is supposed to be. That leads us into the standards and parameters discussions that we follow up with in the 5G process. There's instances where our planning may be incorrect for that part or the production of that part, and there could be theories that the operators make when determining the best processes to make that part. From there, we can look at what we've defined as the standards and parameters, and then walk that through as we create the part and try to turn the problem on and off, and then fix what may be off. Maybe it's the operator that doesn't have quite the information that he needs, or maybe that the standards are incorrect and they need to be modified. With that 5G process, I mentioned that we walk that through with the 5W1H. This is our phenomenon description. This is the tool that we use in determining what the revised phenomena is. So what is the initial phenomena? Well, for us in manufacturing, it's a deviation or gap between the current condition, what we're witnessing, and the desired condition or what should be, and the cause for the gap is unknown. So when we walk through this, the first step is just getting a clear statement from someone that might be experiencing a problem and defining that initial phenomena so we know what the finish line is for us. What we want to get to is the revised phenomena. The origin of the word is Greek, means to make visible that which you cannot see. And when you start walking down this approach, you typically uncover things that you didn't realize was happening in the current state that needs to be revised. I'll give you a great example that we find. We use a micrometer to check sizes of shafts. That is called out in our planning, and what the operator uses that tool to make sure if that part is good or bad. When we walked through that path and we asked 3 different folks to measure that shaft, we found that we got 3 different measurements. And that's what we want to get to in the revised phenomena. It helps us define where our gap is from the initial phenomena. When we look at a phenomena description, we start with this initial phenomena. And in our past, when we didn't get to a revised phenomena, we often find ourselves with this vague initial issue that we had. Could be some superficial analysis or assumptions made when we don't use the 5G and the 5W1H process to understand what we're fixing. And what it ends up doing is it broadens the scope that we're trying to fix. And when it broadens the scope, there isn't clear direction in the terms of being able to fix the initial phenomena that we've seen, and we get very many possible causes. And historically, when we looked at this, those many causals that we identified, Any one of those could have caused the initial phenomenon. We weren't sure exactly where to prioritize our resources into fixing the issue. So when we instituted the 5W1H and the 5G process, we narrowed our scope. This gave us a specific revised phenomena with deep, detailed analysis using the 5G during the 5W1H that helped us not only communicate the initial phenomena, but helped us with the narrowing of the scope for the actual root causes or possible causes. That in turn helped us get to the root cause. So if we look at the 5W1H process, the phenomena description, we're going to start off with the top, and that's the initial phenomena. This is the basic information, dates and participants in the team, and what is the initial problem that was reported. It's just a clear statement on what someone is experiencing. From there, our first step is to go through the containment process. In the containment process, we look at any containment measures necessary, could be damaged or failed parts accounted for, and is delivery to any other customers prevented. Are immediate measures documented and known to all parties involved? So this is typically a cross-functional team for us. What we'll do is send out both or all production, quality, ME, planning to get the containment necessary so we don't pass this on to our next customer. Once this is defined, we start walking through the phenomena description, or the first W in our 5W1H, and that is the what. So what happened? What is the phenomena, and can we reproduce the phenomena? Are we able to turn it on and off? What does it look like? What machine, product, or material, and what size? And how we identify this is walking that process through using the 5G. The next W is the when. When did it occur? When did it start? Often it could be between two different shifts. When we start a new model, as you've seen the models that we make on each product, we have quite a variety of models that we make here. Or when in the process, right? Is this a startup problem? Is this a continuous, intermittent? Do we see a pattern with this problem? Did it happen during shutdown or even a changeover? The third that we look at is the where. Where did we see the phenomena? Where did the phenomena occur? Or where on the equipment or material did it occur? This helps in understanding both the containment, and from a revised phenomena aspect, it narrows the scope or the focus of the resources used. The fourth one is the who. Who is doing it? Who does it affect? Who can generate the phenomena? Is it an individual or group? Is it skill related? In the past, we haven't had a great way to communicate changes from just say one operator to the next. So one operator maybe be on first shift and one on second, and they might be doing things just a little bit different, such as the sequence of welds in a weldment. So when we walk through the 5W1H process, this helps us identify, speaking in terms of the 5G, maybe different theories that operators are using that are causing this phenomena. The fifth one is the which. Which trend or pattern does the phenomena have, or which direction? Which factors influence the occurrence, and is it related to any process variable? It could be in terms of loading parts into a fixture or assembly process if it's not sequenced properly. And this will help us determine that revised phenomena by determining what is the proper sequence. And the last one is the how and how many. How's it being done? What is the extent of the phenomena? Is the process in control, or do we understand fully the process? How has the state of equipment changed from the optimal, and how many times does the phenomena occur? Once we have this identified, we're able to get to a revised phenomena. And what we use is the 5W1H and the 5Ws and the 1H that we just went through to determine the revised phenomena. The result of the properly executed 5W1H is the narrowing of the scope or focus of the problem and define the revised phenomena. This gives us the ability to communicate cross-functionally issues that we've seen through different processes. An example of this might be on a hole, where we start off with the initial phenomena that a hole is oversized in a spacer plate. So you can see in the diagram our desired hole, round, and then what we observed is this oblong, this red dotted line, an oblong hole. When we walk through the 5W1H philosophy, what we get to in a revised phenomena is that the drill is off angle. That revised phenomena doesn't get us to the root cause because we don't understand why that drill's off angle, but that revised phenomena narrows that scope enough into where we can understand that something has caused the drill to be off angle, and we can then walk through the 4M1D, the confirmation, the 5 Ys to understand why it is off angle. The next step in our approach is using the 4M1D and then the confirmation sheet. So the 4M1D in industry standards is a fairly universal tool. It's the Fishbone diagram or the Ishikawa. And this is where we start understanding the contributors to our revised phenomena. What are the major contributors? So when we walk through the Fishbone diagram, what we do is take the revised phenomena and we insert it into our Fishbone diagram as shown. Once we have this transferred, the revised phenomena from the 5W1H, we'll start walking through the major categories of the 4M1D, and that's material, method, machine, man, and design. Some of these don't always fit as the 4Ms could change. Some others that could have an influence would be such as your mission, mother nature, management, money, maintenance. So if those categories don't fit, we'll change the Fishbone diagram to meet what our needs are. As we start walking through the different issues that we have, we'll start filling out the major contributors to what could be causing that revised phenomena. This is typically a brainstorming activity for us after we've done the 5G process, and we start documenting all the contributing factors related to each category, whether it be material, machine, method, man, or design. And once we get this list with a cross-functional team, we'll start the analysis process of those. And we'll get down to what we feel or what we've witnessed is important and take out the ones that are trivial. And what I've seen in practice is if you have 4 or 5, that's typically the max that I see as a contributing factor. If you get 10 or 20, you probably want to revisit the revised phenomena as something's typically off there and you haven't quite got to that point yet. So what we do, eliminate the trivial, non-important causals and cross them off, and then discuss the remaining causes. Decide which are important and circle them. Once we have this 4M1D filled out, we'll then go into a confirmation. Filling out the confirmation is simply a transfer of all important causes that you found on the 4M1D. So what we'll do is we'll put in the 4M category material, man, machine, and method, or design. We'll put the contributing factors, the cause item, what we found, and then we will find a way or define a way to be able to turn this on or off. Once we do that, we'll walk through the confirmation. So we'll put a check on any issue that we found that is okay and what is not okay, and that helps us get to a point where we can focus and get through the 5 whys in determining the root cause. The 5 whys piece, another standard tool from the lean methodologies, is a simple problem-solving tool that helps you identify a countermeasure. When we walk through the 5 whys methodology or the process, we transfer all non-confirmed, not okay effects from the confirmation sheet onto the 5 whys. We start by asking why the problem is happening. And asking why sounds simple, and I've seen this in the industry, but answering it requires thought and an intelligent application. So you can clearly walk the path from the revised phenomena through the contributing factors and then through the 5 whys process. And it gives you a path of how it started. And in terms of how we use KaiNexus, helps us when we look at Kaizen expansion, because we can follow that process and see if we've made that same error, that same opportunity through that process. This must account for the things that we've actually witnessed or happened, and we eliminate the guesses of what might have happened or the assumptions. The number 5 is not important. Continue asking why until you've reached an effective countermeasure and you can go no further. So the past should make sense when you read in reverse using the statement therefore. I'm going to walk you through an example of a machine example that we've used here. So a good example is you discover coolant on the floor from a machine, a leak. Why is it there? Well, the coolant is leaking from the machine. Why is that? It's because the seal was damaged. Historically, this is where we would have stopped and we would have replaced the seal without understanding the actual root cause. If we keep on going further, we'll see that the metal shavings got into the coolant. And why was that? The coolant pump guard allowed the shavings to pass behind the coolant screen. That gets us to an effective root cause. Now we understand what actually caused the seal to go out in the equipment. And it leads us to an effective countermeasure where we can design and install a new guard over the screen. And if we use the therefore theory, we can walk this back. The coolant pump guard allowed shavings to pass behind a coolant screen. Therefore, metal shavings got into the coolant. Therefore, a seal was damaged. Therefore, coolant is leaking from the machine. And therefore, you discover coolant on the floor. So it's an effective approach to understand that you can tell this story and you understand exactly how this coolant got onto the floor. So just as a review from the structured problem-solving process that we use, we start with the 5G and the 5W1H forms. We get to a revised phenomena. We then go into the 4M1D potential phenomena where the contributing factors are identified. Once we have the contributing factors identified, we'll carry those over to the confirmation sheet where we'll fill out and transfer the potential contributing factors to the confirmation, identify which ones are okay and which ones have opportunity to be fixed. From the ones that check not okay, we then transfer those over into the 5 why analysis. From the 5 why analysis, we carry the revised phenomena, the contributing factors, and the 5 why approach. get to the contributing factor root causes that are identified, and then we'll get into the actions or tasks that we need to effectively effectively put in the countermeasures needed so this won't happen. And this is where we get into how we utilize KaiNexus. Step 5 would be to create the task in KaiNexus for our Kaizen to effectively implement the countermeasures that we need. Once we have those, we've also looked at the levels of countermeasures and controls that we put into place. We use 4 different types of countermeasures here at the Heston facility, and this typically speaks in terms of cost and risk. The most effective countermeasures that we put, the defect elimination, error proofing. This is where we can go back through design and design the problem out. The least effective that we have, and typically how we handle is the one-offs that we see, is the defect awareness. So if you kind of walk the path, the defect awareness, that's the use of visual controls, training, documentation, or communication to give operators information that may help prevent this defect. It's just making them aware of that a defect has happened and the root cause of where it happened. Defect detection is a countermeasure that we use. It's a test or validation or inspection the product to catch defects before they are passed on to the next customer. And we put these in place using the quality network that we have, using the quality matrix as well. And this will put a stopgap in front of passing some one-off problems that we see to the next customer by a quality inspection. The defect prevention, mistake proofing, and poka-yoke that we use, mistake proofing the product or process to minimize the chance of making a defect. This could be in terms of using such tools as go, no-go gauges, so they can check or validate the measurement that we are supposed to get by design before we pass it on. Or we could look at a poka-yoke. This is a better tool for us where it can't be installed incorrectly. And then the last one is the defect elimination. It's the error-proof the product or process to completely eliminate the opportunity of the making of the defect. And the design works closely with us in preventing these, making the changes necessary so they don't get passed on to our operators or assemblies or the next customer. So that's our process that we use. I'm going to walk you through kind of a real world example so we can see how this process has been implemented here at the Heston site. So we're going to look at air leaks after assembly. This is in regards to a air ride suspension on our 9980 model windrower that we seen when the new model year came out. So using the 5G process, Gemba and Genbutsu, we went to the occurrence and we examined the objects. And what you can see, this is the air ride suspension that we have underneath our cab. And then this is the pump and the hoses that are used to air up the air suspension. So we walked out there, we examined both the objects and where the occurrences happened. We then go through by design and understand what was design's intent. So we'll pull up the drawings and understand the intent of the design and the components. From here, we can walk through the 5W1H form, and we'll get to the initial phenomena being the air ride leaks after assembly on the 9980 windrowers. We'll take that to a revised phenomena. Using the 5W1H, we got to the air leak on the tractor cab suspension assembly, occurring between both the air hose and the air fittings. From there, we took the contributing factors that we found using man-machine method and material and design, and we identified the contributing factors, which would be the air hose, not to spec, the air fittings not to spec from the material side. From the design side, it could be correct air hoses and fittings used. Did the intent or the design side of it, did we use the correct ones, and are they compatible? And then the method, did we have correct work instructions available to the operators, and did the operators have the correct tools to do their job? From there, we go to the confirmation sheet. So we'll transfer those contributing factors over to the confirmation. We'll look at, from the material side, the air hose, not to spec. From the material side, the air fittings, those both checked good. When we got to the design side and we understood the correct air hose and fittings, you'll notice that this was the first one that was not okay. The incorrect hose was being used for the fittings called out. And then also a contributing factor is that we weren't using the correct tools to install the hose to the fittings. From the confirmation, now that we have what is not okay, we walk through the 5 whys. And we look through the incorrect hoses and fittings being used, and we ask ourselves why. And when we asked ourselves why, we didn't consider the compatibility of the components with the actual fitting to the hose. This, asking ourselves why again, the hose was not approved to use with the push fittings, therefore we couldn't put it together. So if we walk this back, hose is not approved with the push fittings, therefore design didn't consider the compatibility, therefore the incorrect hose was being used for the fittings. You also see this in the same process with the tools being used. So using the pliers and lube when it should be able to install by hand or click by design. Why was that? The incorrect hose was being used with the fittings called out. Why? Well, we didn't consider the hose and the compatibility of the fittings. That leads us into the root cause piece, and then the corrective action or task taken to correct these, to correct the design. So you'll see that the task was to change the hose to meet the fitting specs, and that also eliminated the use for tools from the operator standpoint that changed the hose to meet the fitting spec with the same root cause and corrective actions. And this is how we introduce the issues into KaiNexus. So in our KaiNexus form, what we use here is a PDCA, Plan, Do, Check, Act methodology, where we take the initial phenomena that the ride leaks with the 9980, we get it to the revised phenomena, we understand the root cause. For this one, the inside diameter of the current hose does not match the diameter of the fitting, causing it to not properly seat onto the fitting, and this led to the leaks and difficulty of the installation. We have the solution description, what we need to do. We also enter the tasks associated with that, what tasks we need to do to correct this problem, and then we do the SMART validation. What's it cost the company to have these rejects, plus the cost of the project. And that's how we walk through in KaiNexus to make sure that the proper countermeasures are put in place to resolve the issues and what it costs the company. So in summary, excuse me, we've overviewed the structured problem-solving process, the use of the 5G tool with the 5W1H, the phenomenal description, 4M1D and the confirmation, how that correlates to the 5 whys, our level of countermeasures and controls, and then the AGCO example. So with that, I'm going to turn it back over to Mark for Q&A.
Chad, thanks for the presentation. As we've got some questions already, we'll give a little time for more questions to come in, do a few quick announcements in the meantime. First off, I want to tell you about upcoming webinars. If you're a KaiNexus customer, the ever popular Office Hours series with Ryan Rippey and Matt Banna is going to be held again on May 30th, 2019. It's a great way to learn about new features in KaiNexus and learn some better ways, or learn some new ways or different ways of using KaiNexus software. Our next presentation style webinar that is open to everybody, if you can go back, please, real quick, Chad.
Oops, sorry.
Is going to be presented on June 5th. Our friend and another customer of KaiNexus, Chris Burnham, he is Continuous Improvement Program Manager at Wright Medical. We're still getting the title worked out and finalized, but take a look at www.kainexus.com for when that's posted, or if you go there today, there is a link you can click on to sign up to be notified about future webinars via email. Also want to tell you about some additional resources. We, of course, have our webinars on demand library that you can find. There's a link on the main webinars page. We also want to let you know about our blog, which you can find at blog.kainexus.com. And there's also a tab there. You can see where it says blue and improvement. That's the general blog. There's also a customer blog. Next, want to tell you about something that I've partnered up with KaiNexus on. We're doing a book giveaway. So I'm going to be giving away 3 signed paperback copies of my book, Measures of Success: React Less, Lead Better, Improve More. So that's open to our KaiNexus community. You can go to leanblog.org/KaiNexus giveaway. And if you enter by May 24th, you'll be eligible to be one of the 3 winners of the signed paperback book. And that URL will be in the slides if you want to go and look at those and download them. Again, using the handout section of the control panel, or look in the chat box, or we'll email you a link tomorrow. Final thing I want to mention is our podcast series. Go to kainexus.com/podcast, or you can find us in Apple Podcasts, Google Play, Stitcher, Spotify. We will be posting the audio of Chad's presentation today if you want to revisit that, or listen to it again while you're driving or on a walk or something. That will be part of the podcast feed. We encourage you to sign up, subscribe, and if you like the podcast, please rate and review the podcast as well. So with that, let's go into Q&A. So first off, from Ruben, there's the kind of thank you, and then a question here. He says, first and foremost, thank you for sharing your systematic problem-solving model. With regards to your information on the measurement on the shafts with micrometers, I think it's a statement, good use of gauge R&R with the operators. But his question, and anything else you want to comment on, Chad, he asks, are the micrometers located in a tool crib, or are they in operator toolboxes?
Yeah, so we have both. What we do is there's a calibration sequence that we use. So on certain machining centers, our quality techs will go out and calibrate our tools such as micrometers, anything that we might use. What we find in terms of just micrometers in general is from operator to operator, they hold them just a little bit different. And as we hold very tight tolerances here, what we'll see is just the way that we use them will give us just a bit different value. What this typically doesn't lead into an issue if you're running at nominal, but if you're running at the top of tolerance that we allow with the different operators measuring the equipment, it'll actually kick it out of spec. So what we've found for a better reference or a better tool for the operators is actually go, no-go gauges that aren't operator dependent on how they hold or read the tool.
Okay, let's see. Question from Eric. So what you learned through this discovery in your real life example, did that get applied anywhere else with other products?
It did, and great question. So what we were able to do is we were able to look at our new product introduction as this was actually called out in a different product, and before it got launched in our Kaizen expansion piece that we use, we were able to catch the use of that hose on a different product and stop it before it was released to production.
Great example of spreading that learning. Let's see, Mike asked, how long on average does it take to run through this full process? Is there a recommendation if there's a shorter time requirement? So what happens if you're in a rush? Is it possible to accelerate the process, or does that run the risk of defeating the purpose?
Yeah, and that's a very good question for us, because we initially, when we rolled out this process, we actually put a time frame that we wanted these complete. And what we found is the quality of both the countermeasures and the effective ability to get to the root cause led us to get rid of the time frame. As we understood that we were going to hold the containment activities, the first step in our 5W1H, to hold anything that might be passed to our next customer, whether it be internal or external. We felt the need to really focus on the quality of both the root cause and countermeasures. So we took away that time aspect in this process.
Okay, thanks, Chad. Sue asked, we all know the hardest part of change is sustaining it. How do you make sure countermeasures are sustained through this process?
Yeah, so if you look and both from a cross-functional team, right, we carry both production, our ME group, our planning group, our logistics group, design is in there, our quality group. And when they lead these through, when we look at our level of controls that we put in place, we try to design the problem out so you don't have this issue or have to worry about the sustainment of the countermeasures put in place. And when we start walking down that path and we really look at from the revised phenomena to the root cause, and we struggled at this in the past, and there's often opportunity today. But when you get to the root cause, the countermeasures really become sustainment within themselves. And you don't have to revisit these issues. For the ones that we have that we do, you'll look in our level of controls. The quality group does a very good job at using the quality network to keep this issue out in front of the cross-functional team. They'll do checks for 30, 60, 90 days on the issues that we haven't been able to design out to make sure that they're not coming back.
Got a question from Carlos here. When you do an Ishikawa event or a fishbone diagram process, what's the ratio of experts and non-experts in the process? What's that ratio of the people you invite? Some people like to invite only the experts. Others don't agree because non-experts give a different view. So what are your thoughts on that balance, experts versus non-experts?
Yeah, and that's a good question. And we're structured just a little bit different, and we're structured in a way of value stream. And so we have different value streams that are set up. One's by product from the assembly side, and then it's by core competency on our component side. So laser, fab, machine, weld, Those are our core competencies here. What we'll see is this cross-functional team of both assembly and components meeting together, and through the revised phenomena, being able to communicate this back and forth to each other. So there isn't necessarily an expert that you'd see in there as much as a very well-structured cross-functional team that understands both levels of engagement.
Okay, let's see. So when you have this methodology, who do you give this training to, and how do you go about training and then coaching people on this methodology?
So at our site is right around 1,000 employees here at the Heston site. Everybody's been through the training, the structured problem-solving training. What you'll find is pockets, right? And as we talk about the cultural change that we're shifting through our lean methodologies, you'll see certain people that are experts or really do well in the problem-solving approach, and you'll see some that just haven't had that opportunity or that involvement. What you see, or what I see in this organization, is this gets better with practice. It's an evolution for us. When we rolled this out, we didn't have the 5G process, so we filled the form out, the 5W1H, setting behind the desk, and we made a lot of assumptions. And as you practice this methodology of problem solving, you get better and better. The questions get better and better, and you really start deep diving into the root cause. And what we would see from a year ago to today is when we looked at the 4M1D, every block would have been filled out. To today, you see about 4 or 5 blocks filled out that really understand and correlate to that revised phenomena. And when you get just those 4 or 5 that you see through practice, that root cause really comes out. And then the countermeasures are fairly easy to define once you understand the root cause.
Yeah. Okay, let's see. Jorge asks, how do you involve all employees to have good analysis through this problem solving?
That's a good question as well. What we've found is at the level of communication that you can communicate the path or the initial to revise to root cause is a great determining factor in how well the tools and the practice is being applied. The folks that really grasp the concept and able to run with it, such as our quality department, they can speak very intelligently about how this initial phenomena made it to one of our customers. Some folks that don't have the ability to perform this on a day-to-day, you can see that the answers to the revised phenomena and root cause are typically more vague, and that's where the coaching piece of it comes in. So they'll report out on the revised or the initial revised and root cause, and then that's where the questions start coming up. And if you can't tell a clear story on how you got to the root cause, that's where we can go back and use coaching as one of them to walk through that process again and redefine the revised phenomenon root cause.
Mm-hmm. Okay, let's see. I'm going to combine a couple. There are similar questions here. Is this methodology, how would you compare it to, there's other methodologies like DMAIC, PDCA, 8Ds, Toyota Kata. What would your, I guess, there's, well, let's just kind of throw that at you. There's probably a couple of different ways to answer this.
Yeah. And so we typically use PDCA or DMAIC in terms of projects that we want to roll out, and not in terms of problems that we want to fix. And oftentimes that I've seen in, let's just say DMAIC, and for the folks that are, we can throw out a bunch of acronyms, right? It's define, measure, analyze, incorporate, and control. From a project standpoint, that works really, really well. The change that I would say for us is really in that 5G and that evolution of getting the 5G into our process, because using such as, and there isn't nothing wrong with DMAIC, we typically use that methodology for our projects and not the day-to-day. And I think what you'll see is just the time frame that you use, or that we use in the structured problem solving, is shortened by using this approach.
So here's another question. In your experience, maybe you can tell a story along these lines. Why is it important to narrow down the scope? I mean, you touched on that a little bit, but do you have any other stories?
Yeah, so historically what we've found is we would try to, it's basically eating an elephant, and I'd say that we tried to eat it in one bite, and you didn't get into the details. And I'll talk specifically, one of the things that we look at is the efficiency of our process, right? And we want to make a gain in the efficiency in our processes today. Well, we would look more holistically at the processes and then define projects that we could affect those without really diving into the weeds and understanding issues such as component manufacturing, right? And when you look at it holistically, it gives you a little bit different viewpoint than when you really dive into the weeds and you understand what we're giving or what we're saying is the process versus what is actually being done. And once you dive into that, you start knocking off these smaller instances. It's really eating that elephant one bite at a time for us. And you can see in the Kaizen expansion then that ability of what you found or what you identified as the root cause in one to be expanded, and that speeds up the process for us.
Okay, thanks. And then maybe the last question here, Jorge again. How do you go about a process confirmation of the tools used? So maybe he's asking, how do you kind of oversee if people are using the tools properly? Or I'll add in something else, I was wondering about. It's really tempting sometimes for people to jump into a 5 whys discussion. So either just generally, how do you make sure these different methods are used in a systematic way? And what do you do if someone's trying to sort of jump ahead or jump through steps of this methodology?
Absolutely. So I got 2 ways, I think, to answer this. One is the confirmation, which is it's fun for us to get into the confirmation, the 4M1D confirmation, because what it gives us the ability to do is replicate the problem that we're seeing, that initial phenomena. And we will really analyze in the confirmation whether or not we can turn that problem on or off. And when we get into that confirmation piece, it's kind of the aha moment that we get when we're able to look at what we define as a contributing factor, replicate that contributing factor, and see if it actually turns that initial phenomena on and off for us. That's a really great feeling for the team. The other piece is the confirmation of the process in general. And what we do every Wednesday is we go through the Kaizens, and the folks present the Kaizens to our staff. And what it does is it allows them to tell the compelling story of, here's what we saw. We walked through this process. Here's our revised phenomena. And then here's the root cause that we got to. When they walk through that process, there's questions that are asked, right? And if the questions don't correlate to the root cause that was found, we reject the Kaizen, and we'll then use that time as a coaching opportunity, and we'll walk it through it with them again.
All right. Well, Chad, thank you so much for really informative, helpful presentation. Great practices, really good examples. And thank you to everyone who attended, and thanks for your questions. So you can see Chad's email address is there on screen. If you've got follow-up questions, again, we will be sending out a link to the recording and the slides. If you want to revisit that or share it with others, we certainly encourage you to do so. Check out the webinars on demand library, kainexus.com/webinars. And final reminder on the book giveaway contest, I'll put the link in the chat here. You go to leanblog.org/KaiNexus giveaway. You can enter to win one of 3 copies that we're partnering up on giving away. So there's a link in the chat box. It's in the slides that you'll get sent to you tomorrow. And Chad, thank you. And on behalf of everyone here at KaiNexus, thank you everyone who attended today. Have a good day.
Thanks, everyone.